Welcome! Today we are going to crack a code. A secret code that's hidden inside, believe it or not, every single number. It's a secret that's actually the foundation of modern encryption. And the best part is you're going to learn how to do it right now. So think about this for a second. What if every number out there has its own unique fingerprint? A secret code that belongs only to it and no other? Well, it turns out they do. And in this explainer, we're going to become mathematical detectives and figure out exactly how to uncover it. So how is this fingerprint even made? Well, it all comes down to the fact that every number is either prime, which just means it can only be divided by one in itself, or it's composite. And composite numbers, they're built by multiplying prime numbers together. You can think of primes as the unbreakable, fundamental atoms of the entire math world. Now, this isn't just some fun idea. It's a core law of mathematics. It's called the Fundamental Theorem of Arithmetic. And what it guarantees is that for any number you can think of, the set of prime numbers that multiply together to create it is totally, completely unique. That is the fingerprint. Okay, so we know the what, but what about the how? How do we actually find this secret code? We're going to use a simple but really powerful tool you probably remember from school, the factor tree. Let's see it in action. All right, let's crack the code for a big one, 1,560. We start by finding the smallest prime number that can divide into it, which is 2. And we're just going to keep dividing by 2 until we absolutely can't anymore. Then we just move to the next smallest prime, and so on. You can see the chain, right? We divide by 2 3 times, then we divide by 5, and finally we break that leftover 39 down into 3 and 13. We stop when we're left with only prime numbers. And here's what we found. The unique prime fingerprint for 1560 is a combination of 3 2s, 1 3, 1 5, and 1 13. No other number in the entire universe has that exact same recipe. This is the power of that fundamental theorem we were talking about, right here in action. So cool. Okay, cracking one code is cool and all, but the real power comes when we start comparing the codes of two different numbers. See, this lets us find two really important things. The highest common factor, or HCF, that's the biggest number that divides into both of them, and the lowest common multiple, or LCM, which is the smallest number that they both divide into. And here is the golden rule for finding them. For the HCF, just think common. You only look at the prime factors the numbers share, and you take the smallest power of each. For the LCM, think all. You take every single prime factor from both numbers, and you use the largest power you see of each one. Let's try this out with 45 and 105. First, we find their codes, right? 45 is made of 2 3s and a 5, and 105 is 1 3, 1 5, and 1 7. So for the HCF, what do they have in common? Well, they both have at least 1 3 and at least 1 5. So we multiply those together. 3 times 5 is 15. Easy enough. Now for the LCM. We need all the ingredients from both. We need the 2 3s from the 45, the 1 5, and the 1 7 from the 105. Multiply those highest amounts together, and we get 315. But how can we be absolutely sure our answers are correct, especially if you're, in an exam or something? There's one last elegant little trick, a formula that acts as a perfect check for our work. It is an incredibly handy tool to have in your back pocket. Here it is. It's super simple. If you multiply your HCF and your LCM together, the answer will always be the exact same as multiplying your two original numbers together. It's a beautifully simple way to verify everything. Let's test it with our numbers, 45 and 105. So first, let's multiply our answers. Our HCF was 15, and our LCM was 315. When we multiply them, we get 4,725. Okay, now for the moment of truth, let's see if the formula holds up. Now, let's multiply our two original numbers, 45 and 105. And what do we get? The exact same number, 4,725. Look at that. It works perfectly. This isn't just a coincidence. It's a mathematical certainty. You should always use this formula as your final check. It's the ultimate confirmation that you've cracked the codes correctly. A real lifesaver. So, we've seen that even huge, complex numbers are just elegant combinations of simple little prime numbers. This very principle is what keeps your data secure online through encryption. It really makes you wonder, what other complex systems in our universe are just hiding a simple, fundamental code?